Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from October-November 2022, paper 2. In this lesson, as always, we will discuss these questions in detail so you can improve your conceptual understanding and also you can have better understanding of this topic and also these questions. Let's study together. Let's improve together. The total time for this exam is 1 hour and 15 minutes and total mark for this paper is 60. And you need to answer all questions on this paper. On second page of exam paper, you can find values of some constants and you need some of them for some calculations in your exam. So it's very important to understand that values of constants are given to you. And if you need them, you can come to the second page of exam paper and you can find values of constant. For AS level, you will need value of G. You will need value of C for some calculations. You will also need value of elementary charge. You also need value of 1 atomic mass unit, mass of proton, mass of electron. So these values you need for your AS physics. So this is very important for AS part. And rest of them, they are for A2. So it's better if you can remember them. If you can't remember them and you need values for some calculations, you can come to second page and you can find values of constants. On second page of your exam paper, you can also find some important formulae, but these are not all the formulae you need for AS physics. So rest of the formulae you need to remember by yourself, and also you need to understand how to derive them. Because when you derive a formula, you understand the physics behind that. And that is very important to understand physics. Now let's try to understand these formulae. If you look at these two formulae, you can only use them when A is constant. Means value of A is constant, or simply we can say when A is uniform. And this one you can use for liquid pressure, or we can say for hydrostatic pressure. This one you can use. And the next one is very important. This is about upthrust. And this V is very important. V is volume of fluid displaced. So this is volume of fluid displaced. So you have to understand what is V representing. And next one is for Doppler effect. So this sign is very important. So you can use this one when the source is approaching. You can also use this one when the source is moving away and observer is at rest. If the source is approaching, then observed frequency will be equal to V over V minus Vs. V is the speed of sound and Vs is speed of source, and you need to multiply this one with frequency emitted by source. And if source is moving away but observer is at rest, when the source is moving away, then observed frequency will decrease. So in this case, V over V plus Vs multiplied by frequency of sound emitted by source. Electric current. This formula is also very important. You need to understand what is V. V is the drift velocity, and N is number density, Q is the charge on single charge carrier, and A is cross-sectional area. And these two are some basic formulae. When resistors are connected in series, you can use this one, and when resistors are connected in parallel, you can use this. For question number 1, part A, we need to use informations from table 1.1 to show that SI base unit of alpha is per second. For that purpose, we need this equation. So simply we can rearrange. We can make alpha the subject. So we can write down alpha in this case will be equal to QL divided by R to the power of 4. And unit of Q is given in this table, that is meter cube per second. So simply we can write down this is meter cube per second, and unit of L is given, that is meter, and unit of R is given, you can see here, and unit of L is given here. So unit of R is also meter. So this is m to the power of 4. Now we can simplify. So in this case we will get m to the power of 4 and s to the power of minus 1 divided by m to the power of 4. And this m to the power of 4 we can cancel with this one. So simply we left with s to the power of minus 1. And this is what we need to show for this one. So the answer for this one is here. For part B, we need to show that the percentage uncertainty in alpha is 15%. But alpha in this case is equal to QL divided by r to the power of 4. So in this case, we need to calculate percentage uncertainty in alpha, and these quantities are multiplied and divided. So simply we need to add percentage uncertainties. So simply we can say percentage uncertainty in alpha, this one will be equal to the percentage uncertainty in Q plus percentage uncertainty in L plus percentage uncertainty in R. But R has power, that is 4. So we have to multiply with exponent of R. So we have to write down 4 here. Now if you look at given percentage uncertainties, percentage uncertainty in Q is given, that is 3%. So simply we can write down here, this one is 3%. And percentage uncertainty in L is given, that is 4%. So we can write down this is 4%. Here we have 4 times percentage uncertainty in R, that is 2%. So here we can write down 2%. Now simply we need to add, and the sum of them will be equal to 15%. So this is how simply we can answer this question. For part C, we need to calculate alpha with its absolute uncertainty, and also we need to give our answer to an appropriate number of significant figures. Means we have to consider significant figures as well to write down the final answer. So first of all, let's try to calculate alpha. Alpha is equal to QL over R to the power of 4. So simply values of QL and R are given to us, and simply we need to plug in values and we can calculate value of alpha. In this case, Q is given, that is equal to 2.72 times 10 to negative 8, and value of L is given, that is equal to 2.5 times 10 to minus 2, and value of R is given, that is equal to 7.1 times 10 to minus 5, but the power of R is 4. So we have to be careful with the power. So this is R to the power of 4. So very important one. Don't miss exponent. So power is 4. So if we solve this one, in this case, our answer will be equal to 2.68 times 10 to 7 up to 2SF. You can write down 2.7 times 10 to 7. So this is value of alpha. Now we need to calculate absolute uncertainty in alpha. For alpha, we have already calculated that percentage uncertainty in alpha. Percentage uncertainty means this is multiplied by 100. And we have found that is equal to 15. So we need to calculate delta alpha. So this is absolute uncertainty. So simply, first of all, we have to divide this one by 100, and then we need to multiply this one with value of alpha. And value of alpha is exact value is 2.68 times 10 to 7. So if you multiply this one, the final answer will be about 0.41 times 10 to 7. So now we need to consider number of significant figures. And absolute uncertainty, always you need to write down up to 1 SF. So we can write down this 0.4 times 10 to 7. So this is 0.4 times 10 to 7. And now simply we can write down our final answer. So here it will be 2.7. Here absolute uncertainty is 0.4 because power is already given to you. So the power is 10 to 7. So this is final answer. Absolute uncertainty, always you need to write down up to 1 SF. And then absolute uncertainty and this measurement, they should have same number of dp. They should have same dp. So this has 1 dp. This also should have 1 dp. So these things you have to consider when you need to write down your answer to an appropriate number of significant figures.